Okay, so today we're going to cover some new material. The material we talk about today is not going to be on Quest 3, which is Thursday. So Quest 3 Thursday. It's going to cover material from lessons 14 through 18. So you've already seen everything that's going to be on it. 14 was where we started talking about the laws of exponents. We introduced exponents with the Pythagorean theorem. And then we talked about exponents and radicals, and then we had a little bit of products of polynomials last class, multiplying using the box. If you know another method of multiplying polynomials, you may have learned the acronym FOIL, or you may have seen the lobster claw. If you know either of those, you're more than welcome to use it. So I present the box, but you don't need to use it if you know a different method. Okay, so for Quest 3, covers lessons 14 through 18. You will be allowed to bring the perfect powers sheet and the key formulas sheet. So these are two handouts that I gave you. I will make sure that I have a handful of extra copies in case someone needs to borrow one, plus 1 page of your own notes. So 3 pages total. You are not allowed to bring a calculator. No calculators on Quest 3. But I promise, you won't need it, okay? With the other 3 things that you have, I will not make any crazy calculations that you would need a calculator for. All right, so let's take a look at lesson 19. So we're going to be factoring today. Before we start, I'm just going to tell you that factoring is creating a multiplication problem. It's taking whatever I give you and rewriting it as a multiplication problem. So let's see here. If I give you a multiplication problem of 3x times 7x minus 5, what do you get when you multiply those together? Great. How did you get that? You know the distributive property, yeah. So you multiply your 3x times each term in the parentheses. So we have 21x squared minus 15x. Last class, we talked about how to do that with a box. I'll do that on another page just so I can remind you. 3x times 7x minus 5. Just in case that's not something you knew how to do before last class, I'll show you how I asked you to do it. So each factor, one factor becomes the height of the box and one factor becomes the width of the box. And each term gets its own box. So looking at 3x, how many terms are in that factor of 3x? Terms, remember the definition of terms is that they're separated by addition and subtraction. So how many terms are there in that 3x? 1. And 7x minus 5, how many terms are in there? 2. Okay. So I make my box 1 by 2. Right? And I put my 3x here, and I put my 7x minus 5 up here. It doesn't matter which one goes on top and which one goes on the bottom. You'll come out the same. Then you find the area of each box by multiplying the base, the height, and the length and the width. So 3x times 7x gives you the 21x squared. 3x times negative 5 gives you negative 15x. So I know now that when I multiply those, I get 21x squared minus 15x. And like I said, if you know another method of coming up with that result, by all means use it. I just wanted to remind you that I had presented this method of using boxes last class. Okay, so I can give you the multiplication problem, 3x times 7x minus 5, and you can multiply it together and get 21x squared minus 15x. I could also give you this problem in reverse. I could have you start with 21x squared minus 15x and tell you to factor it. That means rewrite it as a multiplication problem. Okay. So how would I do that? How does that get rewritten? Yeah, 3x times 7x minus 5. Yeah. So this particular problem you knew because we had just done that multiplication problem before. But coming up with that 3x times 7x minus 5 from scratch takes some practice and some techniques that we're going to learn today. All right, so I'm going to multiply a more complicated looking thing using the box method. So 4x squared y cubed, that's my first factor, by negative 3y squared minus 7x squared plus 2xy. That's my second factor. Okay, looking at the first factor, the first pink boxed factor, right? How many terms are in there? 1, good. And in the next one, how many terms are in there? 3. So I set up a 1 by 3 box. 1 term by 3 terms. Each term gets its own space. Okay, so when I want to multiply 4x squared y cubed times negative 3y squared, first you multiply the numbers. 4 times negative 3 is negative 12. And then we look at the x's. X squared times, there's no x's in there, but you could imagine a 1, right? What's x squared times 1? X squared. And what's y cubed times y squared? Y to the 5th. Yeah, like bases, you add the exponents. Okay, so now I multiply my numbers again. 4 times negative 7 is negative 28. X squared times x squared is x to the 4th. Y cubed times 1 is y cubed. Last term here, 4 times 2 is 8, positive 8. X squared times x is x cubed. And y cubed times y is y to the 4th. Okay, so when I multiply these two things together, I end up with negative 12x squared y to the 5th minus 12x to the 4th y cubed plus 8x cubed y to the 4th. But let's say I wanted to go the other direction. Okay, that is, I'm giving you the multiplied together answer and asking you to factor it or unbox it. So the idea here is that we want to find the greatest common factor of all the terms, also known as the GCF. So some lucky people can do this just by looking, right, at the terms and pulling out the GCF. Okay, but here's how to find it if we write it all out. Okay, so first, considering the coefficients, just looking at the numbers in front of the x's and the y's, we've got negative 12, negative 28, and 8. Okay, what's the largest number that goes into all of those numbers? 4. Yeah, 4 divides into all of those. So we'll see 4 is the GCF of the numbers. Now we take the original expression and we write out all the factors, right? Instead of using exponents, write out what everything means. All right, so negative 12, I'm writing it as 4 times negative 3 because I want to use my GCF. Okay, so I use 4 as a factor over all my numbers. 4 times negative 3, and then instead of x squared, I write x times x. Instead of y to the 5th, I write y times y times y times y times y. Okay. My next term, this one here, instead of negative 28, I write negative 4 times 7, or minus 4 times 7. Instead of x to the 4th, x times x times x times x, and instead of y cubed, y times y times y. And then my last term, the 8x cubed y to the 4th, rewrite the 8 as 4 times 2. X cubed is x times x times x, and y to the 4th is y times y times y times y. So I've expanded it all out. Okay. And then I circle factors that are common to all 3 terms. All 3 terms have a 4, right? And I kind of did that on purpose. All 3 terms have a 4. All 3 terms have some x's. All 3 terms have at least how many x's? 2. So I'm going to circle 2 x's from every term. 2 x's, 2 x's. Good. And then all 3 terms have at least how many y's? 3. Yeah. So I circle 3 y's from every term. So we circle all the common factors. I circled the 4s, 2 x's, and 3 y's. So when you put them together, the things that we circled, combine them into a single statement, we have 4x squared y cubed. Okay, 2x, x times x was x squared, y times y times y is y cubed. So this is our GCF, 4x squared y cubed. That is the factor that every single term shares, the largest possible factor. So our factored version, 4x squared y cubed, gets written out front of the parentheses. And then we have to look at what's left, what was not circled. Okay. So in this first term, see, this is my first term all the way to the subtraction sign. The things that were not circled were a -3. No x's didn't get circled, so I have no x's left. I have y squared, a y times a y, so y squared. Okay, in my next term, I have a -7. I took the 4 out, so I'm left with a -7 and an x times an x, so 7x squared. And then in my last term, after you remove the circled stuff, you're left with a 2, an x, and a y. So that is the factored form. We unboxed it, right? We took the multiplied together version and we rewrote it as a multiplication problem. As an alternative, you can use a box for unboxing also, right? So we've got our 3 terms here. We pull out the GCF to the left. So you have to go through all that work to figure out the GCF, which was 4x squared y cubed. And then you have to figure out what goes along the top so that when you multiply times the GCF on the left, you get the numbers, you get the expressions in the boxes. So work with the numbers first. What do you have to multiply 4 by to make a -12? -3. What do you have to multiply x squared by to make x squared? Nothing, or 1, yeah. What do you multiply y cubed by to make y to the 5th? Y squared. All right, what do we multiply 4 by to make a -28? -7. What do you multiply x squared by to make x to the 4th? X squared. And what should I multiply y cubed by to make y cubed? 1, or we don't write anything because times 1 doesn't change anything. All right, what do I multiply 4 by to make 8? 2. What do I multiply x squared by to make x cubed? X, yeah, x to the 1st, I think is what you're thinking of, yeah. And what do I multiply y cubed by to make y to the 4th? Y. So there's another way to come up with the factored form. All right, so that's what we just went through. We did all this already. Okay, so one more time. The process of turning addition and or subtraction into multiplication is called factoring. Rewriting a problem as a multiplication problem is called factoring. So we just did one special kind of factoring called factoring out the GCF. All right, so let's do one more together, and then I'm going to have you try some problems on your own before we finish the demo. Okay, so I have -2x cubed plus 8x squared plus 24x. Actually, you know what? Let's stop here. We're going to stop for now. Pause. And I'm going to have you jump to the activities. And you're going to do number 1 where it says factor out the GCF all the problems in number 1 and stop when you get to number 2. If you finish all of number 1, you can go to the even more practice. Did I miss it? Yeah. When the heck does even more practice start? There we go. You can go to even more practice and you can go, you can definitely do all of these. You can go up to 11. Okay, so it looks like people are mostly, at least through the activities and working on the even more practice. So I'm going to bring us back to the lesson, right back where we left off on page 142. And we're going to start with number 8, page 142. All right, so I'm going to start by factoring out the GCF. We just spent 10, 15 minutes practicing it. So I have negative 2x cubed plus 8x squared plus 24x, and I put each term in a box. So for my numbers, for my negative 2 and my 8 and my 24, what's the largest number that can divide into all of them? 2. Okay, so I put a 2 for my GCF. Then I've got an x cubed, an x squared, and an x. They all have at least how many x's? 1. So I'm just going to put an x here, a single x, 2x to the first. Okay, then I have to decide what do I put along the top to create the numbers in the boxes by multiplication. So 2x times what gives you negative 2x cubed? Negative x squared. Yeah, I need a negative, right? Because my 2x is positive, my answer is negative, so I need a negative. And then x times what gives you x cubed? X squared. Okay. 2 times what gives you 8? 4, a positive 4, yep. And then x times what gives you x squared? X. Good. And then 2 times what gives you 24? 12. And x times what gives you x? Nothing. 1. Yeah. So these two are my factors, right? So I now know that I can rewrite negative 2x cubed plus 8x squared plus 24x as 2x times negative x squared plus 4x plus 12. So our job now is to go a little bit further, and I want to try to factor the trinomial. It's called a trinomial because it has 3 terms. Trinomial inside the parentheses. I want to try to factor that even more. So we'll do that using the box, but it's going to be a 2 by 2 box, which is going to make things much tougher. Okay? It's not just a GCF problem. So we write a 2 by 2 box. And this is kind of a little bit of an algorithmic procedure that just always works, right? So just follow me for a minute. So we put the quadratic term in the top left box always. That's the squared term. Okay? So I put the negative x squared in the top left box. Okay? And then you put the constant term, the number that has no x's with it, in the bottom right box. So I put a 12 in the bottom right. And then you multiply those 2 entries on the diagonal to get negative 12x squared. Okay, quick detour. We're going to come back to this in 1 second, making a little side point here. If I want to multiply a plus b times c plus d using a 2 by 2 box, I've got a plus b, c plus d. When I multiply and fill in each box, I get AC, BC, AD, and BD. If you multiply the product of each diagonal, right? The AC times the BD is my first diagonal. And then my next diagonal will be AD times BC. What's true about those two expressions? They equal the same thing. Yeah. How do you know that? Why? It's just a guess. So let me ask you a different question. When you multiply numbers together, does it matter what order you multiply them in? No. Like 4 times 2 times 7 is the same as 7 times 4 times 2. Get the same answer either way, right? So in both of these, I've got an A, B, C, and a D being multiplied together. A, B, C, D. They're the same. Okay. So I'm going to use this tricky little fact, right? Go back to my problem up here. I know that when I multiply this diagonal, I get negative 12x squared. That means that when I multiply these blanks, that I don't know what they are yet, when I multiply them, what should I get? Negative 12x squared, right? So that's going to be a handy little trick I use to figure it out, okay? So I'm going to list all the things I could multiply together to make negative 12x squared, okay, where each factor has an x in it. So I could multiply a 1x and a negative 12x, a 2x and a negative 6x, a 3x and a negative 4x, and then the same exact factors, but put the negative in the other spot, right? I could have a 4x and a negative 3x, 6x and a negative 2x, or a 12x and a negative 1x. So I have 6 options, 6 things I can multiply together to make that negative 12x squared I'm looking for. Okay. Then we find the sum of each pair of factors. So the first one is done. 1x plus negative 12x makes negative 11x. 2x plus negative 6x is negative 4x. 3x plus negative 4x, negative x. Yep. 4x plus negative 3x, 1x. 6x plus negative 2x, 4x. And 12x plus negative x is 11x. Okay, so remember, this was our original trinomial that we're trying to factor. Negative x squared plus 4x plus 12. We already put the negative x squared and the plus 12 into the box. Okay, so it's now time to deal with this plus 4x, right? I haven't really thought about that guy yet. Hopefully, one of the sums from our chart equals 4x. Is there a sum in here of 4x? It's this guy, right? There are a set of factors that multiply to negative 12x squared and add up to 4x. So those are the two factors that we put in the remaining empty boxes in either order, right? I can put, so I'll put negative 2x here and 4x here. I could switch them. I could put the 4x there and the negative 2x there. It doesn't matter. So now I've put in two factors, two expressions. They do multiply to, oh, sorry, that should be 6x and negative 2x. Yeah, 6x. So those do multiply to negative 12x squared, right? Okay, so we put them in the box. Okay. And then we're going to factor out the GCF from the first row. So just look at the top row, negative x squared minus 2x. Look at the numbers. In the first one, we've got a negative 1. Put a little 1 there if you need to. And in the next one, we have a negative 2. What can I divide into both of those numbers? Yeah, I'm definitely going to pull out an x because they each have at least an x. But I'm also going to make it negative. I'm going to pull out a negative. So I pull out negative x. Okay, so now I have to figure out what goes on the top so that when I multiply negative x by it, I get these entries that are in the boxes, right? So negative x times what gives you negative x squared, x. And negative x times what gives you negative 2x, 2. So positive 2. Good. We are getting there. So now I only have one spot left to figure out. I need to figure out what goes right here. So I've got an x in the upper left here. What would I have to multiply x by to make 6x? A positive 6. And now I've got my two factors, x plus 2 and negative x plus 6. And we should verify that this works, right? I'm going to make a 2 by 2 box. Make sure that when I multiply x plus 2 and negative x plus 6, that I get my original expression that I was trying to factor. So when I multiply these, I have negative x squared minus 2x plus 6x plus 12. So when I write those all out, I have negative x squared. Negative 2x plus 6x is plus 4x plus 12. So I just combine those like terms, and that is where I started, right? That is the expression I asked you to factor. So you can always check when you're factoring by multiplying them back together and make sure you get back where you started. It's also pretty important that I just take the time to write out what I was doing, right? I took my original expression and I factored it, which means I wrote it as a multiplication problem. Rewrote negative x squared plus 4x plus 12 as a multiplication problem. X plus 2 times negative x plus 6. Okay, almost there. We read the factors from the outside of the box. Oh, right, this is what I just did. I just wrote it as final. All right, and so that was actually a smaller part of a larger problem, right? My very original thing that I was trying to factor was this guy, right? If you remember, that's what we started with. First thing we did in number 8 was pull out a GCF of 2x, and then I was left with this trinomial that I just worked really hard to factor. Okay. So at the very last step, we bring it back. We say this was the original thing I was trying to factor. It factored to 2x times a trinomial, and then I keep the 2x and I factored the trinomial to 2 binomials. With practice, using a 2 by 2 box to factor becomes easy. It's a really tough process to follow at first. Persevere, it will get easier. That said, you do not need to use the box method on any test problem. If you have another method that you have learned for factoring, you are totally welcome to use it. The important thing is that you are able to factor using some method. It doesn't matter how you get the factors. Okay, so I've presented the box method, but if you know another one, that's fine. All right, so I'm going to send you back to your activities. You already did number 1, and you can go ahead and start at number 2.